Okay, I'll share my screen. Can you see it okay?
Yep, we can see it.
All right. Good afternoon. We are Team Dragonball SWE, and we are presenting Gator Atlas Sprint 1. I'm your project manager, William, and we are missing Matthew, our Scrum Master, right now.
I am Luna Freya-Wynn, a development team member.
Alex looks frozen. So
Yeah.
His connection might also be at risk. He did
Oh,
say,
man.
yeah.
Well,
Oh,
we can
this is-
keep on pushing forward.
Okay.
Great. Sorry for the trouble.
All good.
So just for a reminder, Gator Atlas is a student mapping service to help students better find like their classes and their schedules at the beginning of the semester, because it's like separated. So our problem was like in 1.uf, we like thought like the mapping service was not like the best, and we wanted to try to optimize that and make it a better experience for students to find like their classes and such. And so that's what we're making with a website. Alex was supposed to use slide, but so our stack that we're doing is the Fern stack. So we decided to do Firebase because we're using Google Maps in our stuff. We just wanted to keep the Google theme going there with Firebase. So Firebase are our database for our backend with Node.js, and React is our front end.
So this was going to be Matt's slide, but I can explain this. Our use case is basically once a user arrives to our site, they log in or create an account. And from there, if they're a new user, they can enter their new class info and then see how long it would take to walk from place to place on the maps. They can also update their info if they've already got info, and from there they can just log out or stay logged in to receive the upcoming class alerts, as well as finding out when they should leave for their class and their schedule and everything they have up to their account. In addition, this is the actual diagram of the, sorry, not diagram, but chart of the use cases, one being for the average user and one being for the returning user. And it's pretty similar in terms of the flow of events and the requirements, with the preconditions changing only on whether or not they've created an account and if they are logged in. The exception points would just be whether or not they have logged in or have an account. And this is the wireframe of the site.
Yeah, so this is what the login is going to be. We made this in Paint. We just did like a quick mock-up. We'll show you what it ended up looking like later, but this is the login screen, and this is the home page. So we want to have a map like in the middle, and there's going to be a toggle on the side, like where that bar is, the vertical bar on the side here. There's going to be a toggle for the classes that you want to get to. And there's going to be a navigation bar at the top, and it'll remind you at the bottom when your next class is and where it is. The FAQ page is just going to have like some text on like helping like users figure out how the system works. And the entering classes, so the class number will be entered here in the side boxes, and then it will send a request to the UF API and get back the information on the location and time of the classes, and that'll be saved to their account for the mapping. So code thus far, this is the current version of the login page. I just showed you the mockup earlier. So just to go in, can you guys still see my screen?
Yep.
Okay, so this is the main app for the React app. This is where it starts out. And that's the screen I just showed you. And on the click for the login, right now there's no backend made quite yet. So the login doesn't really have any requirements. So it'll just reload this example page. This example page brings up a navigation bar and like multi-routing system for React, and all the pages that will be able to route through are up here. Just to give you a quick look at it, this is what I just showed you. This is the login screen. And so if I click login, it routes you to what will be the future homepage. And then the navigation bar up here can toggle back to what will be the rest of the pages that the wireframes described. And we were able to get Maps, the Google Maps API working on a page, but we just have to integrate it into the other pages. So you can see here, there's a toggle for where you want to go, which will eventually be like customized to the user based on where their classes are. And then it will be able to route, walking route through that way. So that is the code thus far.
Yeah, so like Matt was saying, a lot of our development has been front end, so we haven't integrated as many software tests as we would for the back end. So right now we have a simple test that checks if we render the React link properly. So our web page is actually up and running. So in Sprint 2, one of the big focuses is going to be writing the test to kind of further development of the backend to integrate the map API properly and to get the user database integrated. So some of the issues encountered, this kind of goes off what I was talking about with the testing. We were a bit ambitious with our Sprint 1 goals. Looking back at it, we basically set ourselves to code our entire project in Sprint 1. So that's going to reflect our Sprint 2 backlog, just to spread out our goals, which goes on to our second issue of pacing. We didn't spread out our work as even as we should have. During Sprint 1, there was a bit more planning that we didn't anticipate having to be done, and then we did the database for ourselves so we can go on and implement the things like our database and integrating the API with the Canvas API.
Okay, so a review of the Sprint 1 backlog, like as Alex was saying, we didn't get to quite everything. We made the base React app in the front end for the login page like we had hoped, and we got Google Maps to render on a web page. But we kind of like front loaded our sprint, as Alex was saying, and didn't quite get to the back end, like the login portion, the database, as well as the UF API calls, which is what we're going to get to in future plans for Sprint 2. So we're going to continue to make the rest of the pages. As I showed in our demo, we don't have the FAQ page and like the home page quite set up properly, and we need to integrate Google Maps into the site.
Yeah, so a large part of our backend is going to be the login database using Firebase. So first we have to set up the database structure, and building off of that, use the Google sign-in features of Firebase to authenticate our users so they can store their class data and update that as they change classes throughout the years.
So with the Google Maps API integration, we're estimating about 11 effort hours to kind of integrate everything that we want to be integrated for a site, which is just sourcing the API and getting used to that whole API, as well as setting up the API request token system for the site, because it's one thing to use it personally and another to actually have it in a nice way where it's like not in the GitHub. And we'll have to figure out the API interactions with our map canvas object as well.
Okay, so displaying the APIs. So the Maps API, like Luna was just talking about, and the UF API, just communicating between the two and just having them like have a proper like handshake. So that needs to be worked out in the back end as well. And then from there, just spending time just making everything look better and more seamless and smooth, so the users have the best experience for when they're using the site. And that's all we have for you today.
Thank you very much.
Great, thanks. I had a question. Can you, for your backlog, those items that you just presented, Did those include this objects from sprint 1 too? Or is that just sprint 2?
That it includes the overlap from sprint 1, is that if that's what you're saying?
Yeah, can you go ahead and slide back to that?
Which slide?
So, I mean, this series of slides, it includes items from sprint 1.
Yes, yeah, it does. It does.
Okay.
Like everything that we didn't accomplish, we just pushed back into this one. Yeah.
Got it. All right, thanks. Other than that, very good presentation. I liked your slides were set up very well, I thought.
Thank you.
And you managed to explain, each part of this presentation very well, even despite missing a team member. Other than that, Grant, do you have any comments?
Yeah, no, I think he has a really good hit on a crunch, everything we needed. And yeah, he has a very good, like, I know that you can't control network connectivity issues and stuff like that, which happens, but you guys did a good job. Yeah, good job working with that.
Thank you so much. Yeah,
much.
I hope Matt's okay. We were just talking to him not that long ago, so
Yeah,
I hope
Yeah.
everything's fine. But
Yeah, we all checked in like literally 5-10
Like 10
minutes ago.
10
Like we were
minutes,
all
yeah.
here. It's a
Okay.
surprise to all of us. Yeah.
all right.
Yeah.
All right.
All right,
Thanks,
well,
guys.
other than that, you guys are good to go. Thanks again.
All right.
All
Thank
right,
you so
thank
much.
you so
Have a
much.
nice day.
Thanks, guys.